In this tutorial, I'm going to show you my workflow on small-scale fluid simulations, and what we're trying to achieve here is like a smooth surface, and while we keep some foldings. So like all Entagma tutorials, I'm going to show you first what we're doing, and then I'm going to the tutorial. So there isn't like one thing that you do to make it look good, but you do like a lot of stuff, and at the end everything adds together and it looks like smooth and good and with no flickerings. So what I usually do is like 3 steps. The first one is the emitter. So check it out, the emitter here. What I have is a cylinder, and usually you just do like a flip source here and it scatter the particles inside like this. But in this workflow, to keep the shape better, I also do a scatter around the emitter and merge it together with the flip source. Then the next step is the VDB workflow. So you just do like a bunch of operations here in between. Like usually without the operations it would look like this, but then you just do like some operations here to make it look smoother. It won't look like perfect, but then you can do some SOPs operation and it will look a bit better. And I have to say that this workflow doesn't work perfectly for all situations. Like if you have like a different kind of emitter, like squared one, it's way harder to keep it smooth like this, but it works really fine, believe me. Like in most of situations, like this workflow is super good. You don't really need like a really super smooth surface all the time, you know. So let's get started. So first of all, I will start creating a tube, and I'll call this like fluid. And the scale here is really important. You don't want to make it like real life scale because it's too small for flip simulations, but something a bit bigger and like not huge, you know, like small but like not like super tiny. What I found out on my previous test is this scale here. I'll put 0.04 here and 0.2 here. So this scale for the meter, check it out, like this is the 1 meter unit, and it's just like way smaller, so it will cover this area here when the simulation is done. And I will put a transform here to bring it up a bit. And I won't cap this tube here right now because I want to do that scatter thing later. So I will put like a polycap first here, and then I can't forget to change these 2 polygons and give it more columns. So now I'm gonna put a flip source here. I will put a null, call it out source, and I will connect it to a dot network. I'll call this dot network flip. I'll dive inside, and here I'm gonna do something like really fast, but I'm sure you will understand what's going on. So I need a flip object, I'll need a flip solver, I will need a volume source, I will need a ground plane, and I will need a gravity. So now let's organize this stuff like these, here, here. Connect the flip object here, the flip source here. I will get these 2 guys together, and holding Alt on my keyboard, I will drag here and connect it here. Cool. Now, first of all, like I don't know what's up with these huge particles here, so I'll just change here the particles on the guides to, instead of sprites, I'll put it particles. This should be default in my opinion. And then I'll get rid of this subpath, so I don't use the base thing. And now here on the volume source, I will change this to source flip, and then on the input I will use the first context, so it will get my emitter outside there. And right now we can see nothing, and like I will get rid of this ground plane, and if I press like space G here to see the whole thing, it zooms out for this volume limits. And what we can do is like just not visualize the volume limits. Now I will get this particle separation here, and I will copy this parameter, and I will press Ctrl 3 to create a quick mark here. I like always my simulations are always on 3, I don't know why, so I just keep doing it like this. And then I will paste it here on the flip source, on the particle separation as a relative reference. And now let's just see if it's doing something. Yeah, it's here, but this scale is too big, so let's just decrease it a bit. Yeah, looking better now. I will press Ctrl 2 here. I will also put the particle separation on the voxel size, but we don't want it to be like the same as the particle separation, so I will dive inside here again, and I will get this grid scale here as a copy parameter. I'll come back here, and then I will multiply this particle separation, and I'll pass the relative reference here. So now this is the size that I need for the grid, like it's particle separations multiplied by this guy here. And now if I start simulating, yeah, it's working. I noticed that I forgot to put the jitter here, jitter seed, so I usually put $T. And here on the flip source, now there's a couple of things that I want to do. And first of all, I want to change the volume transfer to Swirly kernel. It won't do a lot of difference, but Swirly kernel works better for small scale fluid simulation, so why not? And then here on the particle motion, I will switch on the add ID attribute. I'm pretty sure I'm not using this on this tutorial, but I always switch it on because eventually I change my mind and then I have to do the simulation all over again, so it's like easy to just keep it on. And I will also switch off the receding because it tends to cause some flickering on my simulations. Sometimes like it's really good if you increase this a lot, it looks nice, but like on my simulations I usually try to keep this off. And so I'll switch on the viscosity. Here I tested some parameters earlier, and I know that 1000 of viscosity will work nice on this situation. And now let me show you something. Here it's quite hard to get like a proper coiling effect where it's like spinning, but I'm gonna call this movement coiling so we know what we're talking about. And I can't forget to switch these on. And let me show you something. The frequency of these will depend on the emitter. So a nice way to control this is thinking about this. If the emitter is higher, so if you put like, I'll put like 2 meters here, and let's just keep it pinned here inside of the simulation. So if the emitter is higher, the frequency will be faster. Check it out. It will change faster. Let's play it in real time so you can see it. So it's faster. And if the emitter is lower, like let's put like 0.75, it will spin slowly. So you can control this by height. And another way, let me just show you. So it's slower now, it's not like super fast. So the higher, the faster it will be. And also the thickness of the emitter. So let's put it like here, this height on, I don't know, 1.25. And if the emitter is thicker, so let's put 8, it will decrease that speed as well. It will do like slower coiling. So here in this situation, it's not even doing any coiling. I think I went too high. So I'll put 6. And it takes a while to start doing it, but then it does. So just think like this: thicker gets slower, higher gets faster. And if you make it like super thin, it gets like really faster. Check it out. But something else like is that don't trust on this shape right now, because we're not working with our final particle resolution, and that sucks on Flip because like you think this is looking like super fine now. Yeah, I love this, and then you're gonna make your mesh and you realize that you need more particles, and then you put more particles and it will look like totally different. Also, if you change the viscosity, it looks like it changed just a little bit, it looks like a whole new thing. So the next step now is to find like which particle resolution we need to get like a good mesh. So what I like to do is I will just go back to the values that I know that it's working nicely because I tested earlier, and it's like 0.4 here, 2 here, and the height here is 1. Now here, this is not like the best way to bring your particles back to the simulation, but it's the fastest way. So I'll just like write flip star here, and then I have just like only my simulation. And let's start creating some mesh. So like something that I always forget to put is the fluid compress. So I will put it right now. I will disable these and disable this. So this will save it, like it will get like better on your hard drive when you're saving it. And let's put a null and call these out particles. And let's start creating the mesh. So I'll create a VDB from particles. And first thing I like to do is like decrease this and put here the same as my particle separation. So you don't have to keep these like this, you know, like, but it's a starting point. So I'll paste relative reference here, and I think about it like this. Any value higher than the particle separation will look bad. But like you can get it like lower than your particle separation to get like more details, but like as a starting point, the particle separation size is a really good idea. So now we can see that it's like not good, but the second thing is like just convert it to mesh, so we can see like something closer to our final result. Okay, so it's definitely not looking good like this. Like we can see that the polygon count is too low. So I will decrease the particle separation, increasing the resolution. And on my previous test, like I know that this one will work nicely. And check it out, like what we want to do here is try to keep like as close as possible to this emitter shape. Check it out, like it's quite better, you know, like it's not perfect, but it's looking good. I'm gonna do that scatter thing later to make it look even better. But right now let's just simulate a couple of frames until we see like a folding or something and see how it goes. So in this resolution, the simulation is still fast and it's getting like some nice details. And here, the first two operations I like to do here in between is a VDB reshape set to close. Like, let me just show you something here in case you don't know. This close operation is the same thing as you put like a VDB reshape set to dilate, and then you put another VDB reshape set to erode with the same offset as the dilate one. And check it out, like I got this result, and here with the close I got exactly the same result. So that's exactly what it's doing. Sometimes it's nice to put like a VDB smooth SDF here in the middle. It looks quite nice, but sometimes like in this situation it wasn't looking nice, so I'm not using this workflow. But it's like just so you know it. And see, like this is looking a bit better already, and like I said, you just keep adding stuff so it looks a little bit better, a little bit better, and a little bit better, and at the end it looks like better. So something else that I like to do is like choose the VDB smooth, but you have to use the SDF one, not the smooth, because this SDF one, it have these two options here that will smooth out the surface but keep the curvatures as much as it can. Like if we use the Gaussian, for example, it will smooth really nicely, but it loses the curvatures. And it's looking nice, you know, but we can make it better. And let me just show you like how something you can do to see how smooth it is. It will look like terrible always in most of the situations, but just put like a skylight and change it to an angle like here, so you start seeing some issues. I was really expecting it to look like worse than this, but that's nice. So right now we're not like we're keeping some foldings here, but I think we can get it like, let me just go couple of frames more. we can get a little bit more details, like more harder edges here. So what I like to do is decrease this decrease this voxel size. So I will delete this channel reference and I will put like a smaller volume. Check it out. So it starts bringing back detail, but it starts getting like bumpy. And check it out, like this is too bumpy, it's hard to get rid of this later, but like if I keep it like on 3, it's better than on 5, you know, check it out. But it's like bumpy, and we'll get rid of this with that scatter here. And something else, like check this out, like if I go to the first frame and I'll see my emitter, where is the emitter? Here. And then I will mesh it, you'll see that it's like way bigger than it should be. And with this scatter, it will get like even thicker around it. So something that you can do to make it, oh my god, where is this? So it's here. To make it closer to the size is decreasing the point radius scale. Point radius scale is basically like a sphere, a VDB sphere that it creates around each particle. So decrease the size to look a little bit closer, but it will look more like, it will have like more bumps here, more lumps on it. So now to get rid of it, let's do that scatter thing workflow. So here I'll do the scatter here, and check it out, like I don't need to scatter points on top of it, you know, because I just need on this area. And that's why I didn't cap it here. I just put like a polyfill here. And now, let me show you here. I will press W here to see on the surface, on the front view. And something that I want to do is make it look like a higher resolution than this. Something nice that we can do is put a color here, like pinkish, I guess, and merge it together. So, okay. So you can see, I'm sure you understand what's going on. Like I have a lower resolution here and a higher resolution just on the surface, because I don't really need, like, you know, like if I increase this resolution here, it would look like way smoother, but the simulation would get like super slow because I don't need a lot of particles inside. And also the simulation would look different, so it's pretty hard to control it like this. And with this scatter here, it will look a little bit different, but it will be pretty much the same. And I will keep the surface smoother. Like here, it's still not getting those particles. Let me show you why. So I have these here on the outsource. Let me get rid of this color. And this is what's getting inside. So here, if you have a look on the volume source, the particles have these groups. It's reading all the points that are inside this group. So if you middle mouse click here, you'll see that these particles have this group. So something you can do is just like create a group here and call it particles. It have to be points. Now it's getting inside, check it out. So it's like this, and what's getting outside the DOP network is this. And something else that I like to do, I just like copy this node and I create another group called particle surface. Oftentimes I wanna just like split it here, get just the shell, to scatter, choose like those points as bubbles or something else, you know. It works quite nice because sometimes you don't have to use the inside points to scatter things. It's not like a transparent liquid or something. So you can just get the surface, like, you know, like split it and get here like particle surface. Now let's simulate a couple of frames and see how it goes. I'll simulate 25 and I'll show you like one more things about the substeps that we can do, because as soon as you add this shell thing, check it out, like you start seeing these edges here, and if you mesh it, you can like really notice it, you know. So the best way to get, you know, it's pretty hard to really get rid of it, but you can get it like better than this by increasing the substeps. So I'll just come here to the flip solver, and on substeps, I'll put like max of 4. I usually try 3 first here, see how it goes. And in this situation, I know that it looks better with 4. You also don't want to increase that like too much, you know, because it will get like unnecessarily slowly. So let's see how it goes. So it's like I said, this is not perfect here. We have to do some more VDB operations to make it look better. And also this area here that is falling, check it out, like here it's quite nice here, this area, the area that it's like almost static, but the fast moving ones get these issues and you will have motion blur on this area, so like you don't have to bother that much about this. But let's make it like as better as we can. So something else like that I can do here is put like a VDB smooth SDF before the VDB reshape, and check it out, it's much better already. And you can even try like mean curvature flow, you know. And yeah, I'd rather use the mean curvature flow here, but check it out, like this one looks pretty fine and it's super smooth, but I'll keep the mean curvature flow just to like keep these details here like as much as we can. Let's see how this side looks. Yeah, see, now I lose like a lot of detail here, so I'll keep the mean curvature flow. And I will also use like a VDB reshape to dilate it a little bit, so it gets like better foldings here, in my opinion. And I think for the VDB operations, this is fine now. You know, like it's not a workflow like just put all of these and it will work. Do like I said, start with like these two and then start adding more stuff around it to see how it goes. But those are basically the nodes I need. Like I don't usually use any other kind of VDB nodes. And now to do the last part of it, I will do some SOPs operations. So something you can do here to get like harder edges here on the foldings is use a peak. It's super obvious, but it does work. Check it out. In this case, the simulation will get like bigger if you have like an object colliding here. It won't be like, it may not be like the best solution, but in this situation, it does work like really nicely. I don't need this too much, I guess. Like this is fine. And now check it out. Let's add some normals to it. And when you do flip, you often get like some kind of weird normals here in between, like in some areas, sometimes even here in the middle, you know, like you get some weird normals. So I always get the normal node and change it to by face area. Check it out, like it gets like a bit better. It's not like the best solution, but it does work better. And now, if you have a look like on this side, you can see that you have like these voxels, clearly some lines here going like this from the voxels. And here's something that I learned from Entagma. If you get like the normals and change it to points, you can use like an attribute blur to smooth out the normals. So check it out, like if I start increasing this value, like I can increase it a lot, it gets like super smooth. But no, we don't want to increase it a lot. Let's just look like 10, I guess. Gets like smooth. And because you don't want to increase it a lot because it starts losing these details here, and you don't want to lose these details, you know, like just like enough so you get like a smooth surface. And okay, yeah, that's basically it. Now let's just put like a node here to say that it's out mesh. And just like one last thing is that this surface don't have motion velocity attribute to make motion blur, so I'll just get like an attribute transfer and get here the particles and get the v from the particles. So now if you check it here, it does have proper motion blur and velocity, so it will render properly as motion blur. And yeah, that's it. I hope you enjoy it. It was insanely nice for me to record this tutorial because I learned Houdini from Entagma. Like most of the things, like when I started, it was like a huge help. And it's mind-blowing for me that I can do a tutorial for them now. So I really hope you enjoy it. And I also would like to say a huge thanks to my friend Lobão, who have been studying this workflow with me for like weeks or months now, and we finally came out with this like better solution. And like I said, this won't work like in all situations, but it's a great starting point for all the situations.